Welcome, everyone, to day 2 of the Security Weekly Virtual Hacker Summer Camp. I'm Paul Asadorian, and I'm excited to be here with Mario Vuksan. He's the CEO and co-founder at Reversing Labs. Welcome, Mario.
Thank you, Paul, for having me.
Yes, and Reversing Labs, all thing malware identification, attacker technique identification. Is that a good overview?
I mean, just that's about right. We spent actually more than 10 years, focusing specifically on understanding the binary payloads of different types, figuring out what they do, who they're associated with, what sort of the components they belong to. It's us, pretty good summary.
Yes. And I think the topic for this interview is really not so much about identification, but that's important, but understanding context. And it sounds like you have a newer kind of method to help folks get the context of malware or attacker techniques in their environments.
Yeah, we have sort of started talking this year about something really, really exciting. And, this week also we are expanding the concept and methodology, and are very excited to be able to discuss this with you. And the concept is called explainable threat intelligence. Reason we went down the explainability path is it's wouldn't call it latest and greatest, but like definitely sort of the cutting edge of understanding machine learning types of verdicts. And here, when it comes to security, this is really first machine learning backed classification system that is designed to actually provide insights of what those decisions are, what do they connect to, and how they can actually help the analysts and hunters to do multiple things, sort of from automating their threat intensive research efforts, to better understanding what has happened, what are the relevant components of that, how they relate to the data at large, where does the global evidence can be found about this events, and then improve their productivity by being able to better say what should I trust, what should I not trust, do I understand why I'm making these decisions, and obviously in the process refining your own skills by learning something through additional data, through this explainable threat intelligence concept in areas where historically you didn't have many options, where we pretty much had a set of tools that would give you the binary or very rudimentary metadata about events, which we tend to call really the black box concept, to something where we are all really interested, just like we look at open source and we want to look at security with the full visibility of what happens inside, what's good, what's bad, what do we agree on, and hoping that as the events evolve, we are all smarter in the process.
Yeah, and, having used your product actually back in the day, right? It's fantastic I've got this process. Reversing Labs can tell me it's bad, right? And that was typically the integration. If I wanted more, I could go get that detail, but it was almost like a manual exploration. This was years ago, right? It sounds like you've taken a lot of those artifacts, like not only maybe is that file or that process bad, but here are all the things it might typically do, and allow that automation to build into my system to say, you might want to go look for this file or this registry key or this particular type of behavior because you had this process running. Did I capture that correctly?
Yeah, that is absolutely correct. So we spend a tremendous amount of effort, to provide the really sort of the scalable, efficient, infrastructure that will, to start with, extract all the relevant data before we get even to the classification concept. And then apply sort of all these different layers, of machine learning to it, to be able to connect the data that we've just analyzed and a tremendous amount of information that, we are collecting in our cloud. And just sort of, as a sort of a sense of scale, we process some 8 million net new samples daily, and, have some repository of, 11 billion plus objects with all kinds of metadata. Of course, this scale, you really need to be able to process things really quickly. So we tend to spend less than 5 milliseconds and analyzing single extracted object. And that sort of provides us this, additional information that, when you're looking to analyze something, you want the data, you want the classification, and then also you want something to really help you in the human legible language explain what is this, why is this important, for this particular assessment, this tie into this malware family name, to this actor, and then also tie it to external events. There are so many things on the outside, there's so many IOCs, others files, that could be relevant for you to be convinced, whether you need to take the step A, step B, or so some other investigative, process to move the event, further.
Right. Yeah. And, a lot of this has been manual analysis for me. And when you say you're analyzing samples at 55 millis, that's way faster than a human can do it, right? So it's nice because this is in the past, right? I'd see malware and then maybe I do some of the reversing myself and go, yeah, it creates this file and it talks on this port. And then after that whole analysis is done, then I got to go maybe to my firewall logs or whatever and say what's talking on that port. I got to go to my other management system and say, does anyone have this process or this file that it creates, right? It sounds like you're streamlining that and providing all of that data in a nice feed that I can then automate in my environment.
Absolutely. So, we do understand that, manual analysis is always very important. After all, if you're, working for enterprise, you're looking for those, odd, random events that buck the trend that, nobody else detects, that are new and unknown. So you want to spend time with them. Usually when you get to those events, you start thinking like, well, what else is available? How rare is this? Am I following a false lead, or this is something that has happened here and there in my environment or to somebody else, globally. So what we're really trying, with this great scale is to provide responders with as much data, as much clarity immediately, so they could zoom in into the areas where there's lots of juice, where your time is very valuable and should be applied to a meaningful end. And that's for all these efforts that we have done at processing thousands of file formats, applying the behavioral analysis to anything that can or cannot run, and then tying it to anything we see in our cloud with pre-computed classifications and more, is sort of essential part to get you to a proper outcome, and then to come up with a decision that could be nicely orchestrated with the rest of the source SIM and other API-based infrastructure.
Yeah, Mario, it's interesting. One thing that I've observed and have in my own head as a classification when I analyze malware is I'll look at it, and one that sticks out in my head is like, they copied a binary on Linux that was Python spelled wrong, and they copied some files to temp, and the things that they dropped weren't packed or encoded in any way. And I made the determination as the malware analyst and said, this is not very sophisticated malware, right? I'm assuming you also have some level to, in an automated way, find or determine and classify the sophistication of the malware, right? Because that may determine my response.
Absolutely. I think, both unsophisticated and sophisticated, are super ultra relevant,
Yeah.
So once you get something sophisticated, that's the time where like, okay, I'm going to, make myself a cup of coffee. I'm going to take it slowly.
Right.
Let me try to figure out why was it necessary for somebody to put together a complicated piece of malware. Of course, those are usually fewer to come by, harder to put together. There's definitely more value to get there. But also the simpler things, could be really great, false flag mechanisms, people canvassing sort of those early stages of the kill chain. You just want to figure out, what's the level of sophistication organization, where do they have holes? Can you be doing reconnaissance or even scanning of the network if you're all of a sudden on the inside, without being really pinpointed in an easy fashion? When something is simple, probably on the outside there are thousands of componentry. There are tens of groups of different colors, from APT to criminal groups, utilizing this technology. So being able to process that on the inside to kind of distinguish different the command and control infrastructure, and then connect it to whatever is available on a global level, allows you to start sort of zooming in. Hey, I'm gonna for now leave that sort of set of simple attack components and focus on something else instead.
Yeah. Yeah, because we've all been there like, oh, this is run-of-the-mill malware, and we're able to detect it, and it's not. Also, I think the level of destruction, I guess, would also be probably a classification that you have, right? Like, is it really advanced and the attack is ransomware, right, and poses potentially a great threat? Or, is it that just the initial stage dropper that, like you said, there might be dozens of groups on the internet that are criminals that are reusing that code, and all of that also determines the response is how impactful that particular malware or malicious process can be, right?
I mean, we go into sort of really exceptional detail in sort of identifying the ransomware, the rats, droppers, to try to tell people like this is this kind of component based on its behavior, how it was built. It's similar to these other sets, and then also if there is associated IOCs, that's obviously put together, and sometimes those IOCs could be derived from sort of dynamic set of activities, but also frequently from actually automated reverse engineering of the configuration settings that are found inside of a rat or a malware family. Those become really, really interesting because those are relevant from being able to distinguish run-of-the-mill garden variety component being used by a criminal group, APT group, or just potentially even somebody sometimes internally. I mean, we should not forget that organizations do pen testing day in, day out, usually multiple groups. There is attack code flowing in everybody else's networks, and being able to distinguish what is sort of benign desired process versus something that's definitely something worthy of investigation is, I think, a very important distinction to make.
Mario, what are some of the most common ways that organizations are integrating and trying to automate and put your data into a workflow? Are there some common kind of ways in which they're used?
So for us, of course, whoever is building the malware analysis labs and has sort of all kinds of gears, having static dynamic analysis, picking up threat intelligence from the cloud, should find a place for reversing labs, because we really have the state of the art, static plus explainable machine learning and other threat intelligence data set that would be extremely relevant.
Right. Saves them huge amounts of time, basically.
Exactly. It's very relevant, and it enriches then the events that they normally would spend hours and hours of analyzing. So there's a lot of value in it. But more importantly, if the system is given the access to as much data that the organization has, email data, downloads data, the CI/CD data. I mean, we really don't really care whether we're investigating the installers, components, containers, VMs, emails, or whatever. We provide sort of this very interesting centralized pipeline for understanding not logs, but binary content that comes into organization, or organization is getting through the web app, mobile app, that's sitting in an S3 bucket that's being shared, with trusted partners and so on. And then once that workflow is in there, you all of a sudden get this tremendous amount of coverage against the formats that potentially are impossible or difficult to detonate. So you're looking for malware, you're looking for evidence, behaviors, interesting metadata to pivot on. I mean, and then more importantly, it gives you a wonderful custom stream of putting your own protection against. We're seeing many organizations these days relying on their internally developed tagging or protection mechanisms, many times using Yara. And we would support this at grand scale, and then integrate it into their SIEM and SOAR infrastructure, which sort of gives organizations very easy way to add another level of protection. Sort of do downloads, move to email, go to the cloud complexity challenges, which then really gives them sort of new modern architecture that is very useful with the digital transformation projects, especially now the COVID, the work from home. many organizations are trying to figure out, how do I move to something cloud, reduce the reliance of servers internally? I don't know if my IT will have access to my systems, to the buildings.
Right.
We need to sort of, work on stability. At the same time, we need to then start moving the applications to a different, form factor for which, traditional layers of security may not be available anymore.
Yeah, and it sounds like it's closing that loop of there's bad stuff out there. I think I have bad stuff on my network, right? And I verify that, and then I can spit out a YAR rule and go remediate that, right? Or do a further investigation, right? It's closing that loop. I feel like over time we've had pieces, but now they're coming together nicely in these platforms.
Correct. Absolutely. So the other thing is, as we are kind of, thinking about modern architectures going to a cloud, all of a sudden that sort of, the Windows-centric world is starting to be really mixed up. You're having lots of IoTs, many of them running different versions of Linux, all kinds of, scripting languages like, Python and Perl over there. And then, people from home, increasingly utilizing, Mac. And then certainly the cloud apps, having a strong affinity towards, open source and Linux-based systems. Now, kind of the content you're inspecting is, more and more falling in those categories for which, 20 years of security industry was not really built for. So when we go into organizations, we tend to see that, 2/3 of the things that, we highlight and have this, explainable reports for, will never detonate. 3/4 of things, that arrive to the endpoint, would not be, identified by any other means because, they kind of fall outside of, the typical malware categories that we have been accustomed to tracking.
Great stuff. Mario, thank you so much for appearing on Security Weekly. Those that want to learn more, make sure you visit reversinglabs.com. Mario, thanks again.
Oh, thank you so much, for this. I greatly appreciate it.
Stay tuned. More interviews coming up next.